Welcome back to the nightclub. I'm in class. Today we're doing natural logarithms. Yesterday we did what kind of logarithms? Do you remember? Common logarithms. Very good. Common logarithm just means the base is what? 10. Natural logs, the base is the number e. Okay? So the number e, it is in your calculator. It's like pi in that it's irrational, but that's where the similarities end. To get e, you hit second and the division sign, okay, and that is e. And if you hit enter, that's the big long decimal. It doesn't ever repeat or stop. It just keeps going forever. Okay. It kind of looks like there's some repetition to it, but there's not. Okay. What I had up here earlier, this is how you get e, okay? 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial. If you have forgotten what the factorial means, 4 factorial means 4 times 3 times 2 times 1, okay? So that would be 24. All right, if you put that in your calculator, there is a way to get to that button in your calculator as well, just in case you're inquisitive and want to know. 4, you hit math, scroll over to PRB or PROB, and number 4 right there is your factorial, and then you hit enter, and it's 24 just like I said it would be, okay? So for E though, it would be adding all this up. This is called a series, right? Okay, when you add up a whole bunch of numbers. And there's a pattern to it. And the reason it never ends is because you never stop what to the end? You never stop adding to the end, okay? These numbers keep getting what on the denominator? They keep getting bigger and bigger and bigger, which means the overall number keeps getting what? Smaller and smaller and smaller. So eventually, we're adding numbers that are so small that they don't affect this up here. They are only affecting behind it. Is that making sense? Okay. So this is kind of like the rounded answer for E. Okay. But they use E in lots of things. There's we talked about interest the other day. When you're doing compound interest, when we talked about it doing monthly or yearly or whatever, if you have continuously compounding interest, they use the number e in that formula to figure out what that would be. Okay, so e is also used on the Richter scale thing sometimes as well. So y'all know what the Richter scale is? We don't have a lot of them here in Mississippi, but it's how they measure the power of an earthquake. Okay. Anyway, so when I say it's a base e, this is what I mean. When it's a natural log and you have a natural log button, it says LN. Why it's not NL, I don't know. Sorry. They didn't converse with me to, they didn't check with me to see. Yeah. So, log naturel, I guess. So, you may have learned it a little bit in Algebra 2, yeah. If you got the logarithm. If you get to logarithms, you usually learn this too, okay? So, natural log is the same thing as the log of base E. Okay, just understand your base is E when you're doing natural logs. And so this first example, it says convert the log base 6 of 254 to a natural logarithm and evaluate. This is the same thing we did the other day. You're just using natural logs. Okay, we changed the base of our logs yesterday. Remember how we could change the base? And that's basically what you're doing here. You're changing this log using the change of base formula. So I would put natural log of 254 divided by the natural log of 6. I guess I should have wrote it again over here. Log base 6 of 254 equals the natural log of 254 divided by the natural log of 6. So put that in your calculator. Tell me what you get real quick. 3.0904. I'm going to trust you. Actually, I'm not. I'm going to check you. Hey, you're right. 3.0904. Any questions on how to do that? You got what now? Did you put natural log on the top and the bottom? did you put parentheses after 254? Good. All right. Everybody good on the first example? Pretty simple. Moving right along. Example 2. We get to solve this just like we did yesterday. Well, the only difference is instead of log, it says natural log. Okay? Everything we did yesterday applies to today. So what would we do first here? Divide by negative 16.25. And we'll have the natural log of x equals whatever 6.5 divided by negative 16.25 is. That is negative 0.4. Okay. What is the natural log's inverse? Anti-natural log. Okay. I want you to understand what the anti-natural log is. It's e to some power. Okay. So watch what I do here. I'm going to do e. You may have never done this before. I'm going to make both of these exponents. Okay? And you're like, can you do that? Yes, you can do that. I'm going to say e to the negative 0.4 equals e to the natural log of x as a power. Okay? Why can we do that? Because everything is still equal. Okay? We've gone the other direction many times. Remember the other day when we first started doing these, we tried to get the bases the same. And as soon as we did, all we had to do was set the exponents equal, right? That's all you're doing here. Okay, you're just going backwards. The exponents are already set equal. We're just now putting them back to being exponents. All right? Why do I want to do that? Well, because this e and to the natural log power, what do? They cancel each other out. So that goes away. And you're left with x equals e to the negative 0.4 power. And if you put that in your calculator, you get 0.67. I don't know why what's after the 7? 0.3. I don't know why they didn't put the 0.3 on there. Sometimes they round to 2 places, sometimes they round to 4 places. I don't get it. All right, that's just the book's preference, I guess. Everybody good? What if that had just been regular log of x? How would we have gotten rid of it? What would we have made our base? You do the anti-log, but it's 10, right? The anti-log of a log is just base 10, right? Okay? Last example. We don't have very many. Example 3, let me read you the directions. It says solve each equation or inequality by using natural logarithms. So we can solve this many ways, but they want us to use natural logs. So, first thing I'm going to do is take the natural log of both sides. Okay? Everybody see what I did there? No surprises? Since they are now logarithms, what can I do with those exponents? Where can I move them? I can move them to the front. So 2x times the natural log of 3 equals x minus 1 times the natural log of 7. And very similar to yesterday, what do I need to do next? Distribute my natural log of 7 over. So x natural log of 7 minus the natural log of 7 is still equal to 2x times the natural log of 3. What would my next step be? I need my what together? My x's on the same side, so I would move my x natural log of 7 over. Those cancel, that makes 0, and I'm left with negative natural log of 7 on the right side. Can I subtract these on the left the way they are? No, okay? They're not like terms, so I can just factor out what? What do they both have? The x. I can take the x out front, and I'll have 2 natural log of 3 minus the natural log of 7 left. And finally, for my final step, divide by 2 natural log of 3 minus the natural log of 7. What do you need to remember to do when you put this in your calculator? Put parentheses around that bottom. Otherwise, the calculator will give you the wrong answer. you should get negative 7.7433. Okay? Any questions? All right. That's pretty much all the lesson is. We're going to continue on the video. If you want to keep watching, we're going to do some more practice problems. It's y'all's homework, or classwork, I guess we can say. The first 6, I think, are all calculator problems, so you're just plugging them in. So I'll give you a second just to get out your calculator and make sure you got it working good. And as I said, the first 1, 2, 3, 4, 5, I think it's 6. Yeah, the first 6 are strictly calculator problems. Okay? So, probably not. So, all you're going to do, I'm going to pause the video and give y'all some time to work it on your own, and then I'll start it up again. All right. So, check your answers. I'll write them up here for you. The first one should have been negative 0.2705. 21 should have been 0.9657. 23 was 2.2322.
Jordan Van has a checkout.
25 should have been 1.2134. 27 was 0.9966. And 29 was 0.2417. Did we have any issues there? Easy enough putting it in your calculator. Everybody good? 31. Also, putting it in your calculator, but it does want you to use natural logs. So, these are the ones where we're going to use our change of base formula. Remember, I told you when you use your change of base formula, you can make the base what? Anything you want to. These directions want us to use natural logs, so we're going to change the base to e. Okay? So this would be the natural log of 36 divided by the natural log of 5. We're changing the bases and dividing. Okay? And then you just stick that in your calculator. This one would be the natural log of 0.512 divided by the natural log of 8. And this one would be the natural log of the square root of 288 divided by the natural log of 5. And from there, you're just sticking them in your calculator. Again, make sure you put parentheses where they go. Again, I'll give you a few minutes, probably 1 minute, to calculate those, and we'll be back with the answers. All right, so for this one, you should have gotten, y'all tell me, what should you have got for 31? 2 point what? That's correct, 2.2266.
And then negative
33.
negative 0.322.
322 or 3219, yes.
Okay.
3219. It's all tomato, just depends on how you round. How about the last one?
1.7593.
Excellent. 1.7593.
Thanks. I'm trying to get excellent.
Okay. Any questions? Those of you that missed it must have had to have done a button wrong on your calculator or something.
Do we have to put the 0
If you don't put the 0, just make sure you make that point very where I can see it. It's very bold.
Mr. Bragg
Okay.
killed us for putting zeros in front of us in 6th grade. And I haven't since.
She didn't want you to put zeros in front of it? Why?
I
Did
don't
she
know
say why?
Like, I haven't wrote a zero in front of the
Oh.
decimal since.
I just wonder why.
I have no clue. You remember that?
Mine always made us
See, like,
like
did I?
I do it. Well, I like doing it because I've had, you know,
You can't see the
when you see especially when you see a zero, you're like, oh, then that's a decimal when it starts with zero. Because y'all, I know y'all don't believe this, but teenagers sometimes don't have the best handwriting. And I shouldn't say teenagers, people in general. But they'll put like, and it's like, it's barely a little, like it's barely, I can't tell if it's where they erased and, you know, didn't erase all of it or something, but you can barely see it. And I'm like, was that supposed to be a point or something? Anyway, I'll take either one. I'm not like that. All right, 37. 37, we actually start solving them. I'm actually going to show you two ways. I'm going to show you the way I would do it. Now, the directions in your book, again, say to use natural logarithms to solve it, okay? So we're going to do it their way too, but I'm going to show you the quicker way, all right? So there's always the book's way, wanting to teach you how to use what they're saying, and then there's the other way that's just a lot quicker, okay? We've talked about this yesterday. If I wanted to get rid of that base 2, I would need to take a log that's base what? 2, okay? So I would do this one if I had the choice. I would take log base 2 of both sides, okay? Reason being, these log base 2 of the 2 would what? Cancel out, and I'm left with x equals log base 2 of 27. And then I can stick that in my calculator, okay? The book wants you to take the natural log of both sides, okay? So the natural log of 2 to the x equals the natural log of 27. When it's an exponent, where can it go? It can go in the front. So x natural log of 2 equals the natural log of 27. Divide by the natural log of 2. And you put that in your calculator. Either way is correct. Okay? They will both give you, if you do it right, 4.7549. Okay? So like I said, my way is a little quicker, but they're wanting you to use your natural logs and your properties and all that good stuff. On the test, I don't think I specify which way to do it. Okay? You can do it whichever way you want to. Wednesday. I'll give you
Is that the day that we're making up our test? We're making it up. Next Friday.
Friday. Yeah, next Friday. Monday we'll do I'll give you the review to this. Tuesday we'll go over the review to this. Wednesday you'll take the test on this. Correct.
And then when do we take our makeup?
And then Friday will be your makeup.
I mean, our reading.
Friday.
No, it's our makeup.
Oh, are you talking about the one you met Monday?
Like this
When
Monday?
yeah, while they were doing their review. If you weren't here that day before we get out for Thanksgiving, yeah. Okay. 39. Again, you tell me. If I were doing it, I would take the log base what first? Log base 3, because that would get rid of that. Okay, but I'm going to be a good little boy and do it like the book's asking. Take the natural log of both sides. That x comes to the front. And we divide by the natural log of 3 to get our answer. Those cancel. And again, if you put everything in your calculator correctly, you should get 1.3155. Okay. All right, 41. Same thing, but it's a what? Inequality, but you work at the same. I want to take the what of both sides? Natural log of both sides. Now we do get to do a little shortcut here because I don't have to take the time to divide or move this exponent here. Why? Because the natural log and the e do what? They cancel. They are the same base. So I can just go bye-bye. Okay? 0.1 t is bigger than the natural log of 60.3, and we just divide by 0.1. If you put that in your calculator correctly, you should get 40.9933.
So T could be 40.9934.
It depends on what that next number is. If
It's 2.
okay, so it would stay 3.
So I'm saying it would work, like T could be a 4.
Oh! Yeah, because it's bigger.
Yeah.
Yes, T could be 40.9934. Yep, because it's bigger. Okay, I got it. I thought you were talking about the rounding part. My bad. 43. Do we take natural log first here? No. Okay. If you haven't noticed, you don't do natural log or logs until you get your base all alone with its exponent. Okay. So what do we need to move first here? 44. It is multiplying, so we're going to divide by 44. That would be 1/2 equals 1 minus e to the 2x. Is it time to do natural log yet? No, because we can move what first? We can move the 1 over by subtracting, because it's adding and subtracting here to this negative. So 1, -1, 1/2 minus 1 would be -1/2 equals negative e to the 2x. Can we do the natural log yet? No. We can still divide by what? -1 and get rid of that negative. Positive 1/2 equals e to the 2x. And finally, now we have our e all by itself. Take the natural log of both sides. That takes out the e. 2x equals the natural log of 1/2. And my last step is dividing by 2. X equals negative 0.3466. All right. Everybody good on that one? Piece of cake, no questions. That's either good or bad, one or the other. Let's hope it's the good. 45. Just to make this one quicker, I think we only got, what, 2 left? Yeah. We're just going to do these the way I would. I'm going to do it the quick way, okay? Just to show you. You still get the same answer. So, if I wanted to get rid of the base 5, I would take log what? Base 5, okay? So, I'm gonna not do what the directions say to do and do it the quicker way, okay? These do what? Cancel each other out. I'm left with x is less than or equal to whatever log base 5 of 7 square root of 6 is. And you can do the change of base formula, or you can do your log base button in your calculator. Okay, do what? Oh, you go to math and you scroll up and it says log base, and then you can put the base as whatever you want and then put what you're taking. So you'd put 5 in the little box down at the bottom, and then 7 square root of 6 in the box next to it. And when you do that, you should get for 45 1.7657. And that's the same answer we would have got doing it the book's way. Okay? last one. I'm a little disappointed because I'm not going to use logarithms at all here. What power do I need to take this to? The 3/2 power. The reciprocal power. Because again, power to a power, you multiply the exponents. Those would multiply to be 1. X is greater than or equal to 27.6 to the 3/2 power is 144.998885, excuse me. Okay, that is our lesson. Hope you enjoyed it. See you next time, and as always, stay above the line.